Welcome to this new webinar about Inpho Venture Summit and our journey to Inpho. I'm very pleased today to welcome on board three pioneers in quantum technology. We started speaking about quantum technology at Inpho since 2018, I think. You will correct me, Philippe, if I'm wrong, but I think this is the date. And we are very interested to discuss with you, leaders and pioneers, about quantum investment opportunities. We think that the timeline is accelerating. We see more and more investment and huge investment done by a very promising company. So that's what we want to speak about today. So I'm very pleased to introduce you three key speakers. Johan Boulet from NACIDIS Center. So NACIDIS is a recognized technology center focused on quantum technology from Nouvelle-Aquitaine region, but with a national leadership. And happy to hear more about NACIDIS and what you're doing and your focus. Hello, Johan.
Hello. So thank you very much to introduce me, and thank you for the invitation, Géraldine. So yeah, I'm Johan Boulet. So I'm not especially a quantum pioneer. I come from photonics, but I hope that we'll have a little moment to show that both technologies are joined, and this is the reason why it is very interesting to discuss about it today. So I have a background of 20 years in laser development, and since 4 years I am in charge of two plants, one which is Neo-Aquitaine, you mentioned NACIDIS, but also at the French level, which is Atom Control, the development of a supply chain for the lasers for cooling the atoms, especially for quantum computing.
Great. So we will review all this through the questions, and you can give these anchors through the answers to the different questions I will ask. Thank you, Johan. We have also on board Olivier Tonneau, very well known as a founding partner of Quantonation, a leading investment fund. Hello, Olivier.
Hello, Géraldine. Nice to meet you, and well, glad to be here speaking alongside Johan and Philippe. So at Quantonation, we are an early stage fund dedicated to quantum technologies. We started our first investment in 2018, and we are now managing an early stage fund, well, two early stage funds for a total of 325 million euros, more than 40 investments worldwide, and also looking at a few adjacent technologies. So it's mostly quantum, but we're also looking at a bit of photonics enabling technologies, and yeah, happy to speak about the development of all this in the recent years.
Thank you very much, Olivier, for being with us. My next question for you before, after actually Philippe introduced himself, will be why you launched Quantonation in 2018. So very always interested to understand the drivers that drive your decision. But first go to Philippe. Philippe, you are also a pioneer in quantum technology. I have the chance to know for many years now, also related to the activity we are running in Nouvelle-Aquitaine and Bordeaux region. You have a lot of different activities. Also one of the founders of NACIDIS centers, we just spoke before. You are also very active in QDNL, Quantum Delta in Netherlands. Happy to have a very short introduction about yourself and why you have decided to focus your activity on quantum technologies.
That's very nice to be in this webinar with some well-known friends that we I think we follow each other for a very long time. And the first time I was at Inpho, I was actually pitching for a small startup that we were initiating in Nouvelle-Aquitaine. So that's a long time ago already. So I'm currently indeed working for QDNL in charge of this foundation, which is executing the National Growth Fund program for quantum technology in the Netherlands. So we're basically covering, let's say, the whole chain from basic science, which is still extremely important to get quantum technology to the market, but all the way to also the market and to how we can build a quantum industry and how we can make the value of the Netherlands from like the well-trained scientists, engineers that we have, and also the major startups that we have there. How can we make this ecosystem play a significant role in the growing, and I think that's probably the topic of today, in this growing market that is blossoming in quantum technologies today.
Perfect. So I also invite our participants to ask all your questions. At the end of the session, we're going to have a Q&A session, so don't hesitate. You have on stage with us leading players, also investors, so always good to have this ability to ask your questions. And I know them, they will answer, so don't hesitate. This webinar is part of Inpho Venture Summit. Inpho is a really recognized investment event. It's more than an event. It's really a gathering of deep tech investors. We are running Inpho since 2008, so now we have a very interesting and attractive track record. And the Inpho will take place on the 21st and 23rd of October in Bordeaux, as always. What is interesting is that we are here to answer the question, what's next to invest in deep tech? What is the next frontier in deep tech investment? As I was introducing before, this topic of quantum, we started discussing about it in 2018, where it was more like a hope, maybe a hype. Some of the investors were saying, you know, physically, technically, I don't see how it could emerge. We see some very interesting sign right now. So this is what we wanted to address with this after maybe 8 years, just to see the progress and why we are in this position now to speak about quantum. And also interesting for you to know is that all the company that took part to Inpho has raised money. And in total, we have raised for company up to 1.4 billion euro, and they were all early stage. So Inpho is also evolving. We are doing more and more scale-up companies as well. And I think this is also a topic on your side, Olivier, at Quantonation. We are not only focusing on early stage, but I think you are also evolving to support further the company. We could discuss about that. So interesting session right now, about 1 hour altogether. Don't hesitate to ask your question. I just add also that Inpho, as I said, is not an event. It's really a gathering of leading investors, and we benefit from a very strong, we call it editorial committee, but it's really an investment committee to select the company joining, because we have limited room and we really want to have active interactions. So we are very selective in the people invited to join. The goal is to make it happen, to make sure that company will grow and to provide the best condition for success. So now I make my introduction and I'm jumping into the question, but I will start with another question I just said before, and I'm very interested in your point of view, Olivier. When you started Quantonation 2018, what makes you think that it's a good opportunity for investment, where it's a bit crazy? Huge capital needed for quantum technology. A lot of people were saying, oh, it's not physically possible. So let us know.
So you're right to say that when we started, the type of question we were asked were a bit different. So first, people were trying very hard to understand what is quantum physics and what are those magical properties, how does it work? Now it's a bit different. We have computers, they are deployed in data centers. So the question is not about what is it and how does it work, but more what can we do with it. So it has evolved over the year, but you're right to say that in 2018, it could have seemed a bit crazy. Now, if you think about it, we had Christophe, my co-founder, who was already in the Silicon Valley working for a quantum startup doing software. And back as soon as 2016, IBM had put the first qubit online. So people could start developing algorithm and play with it. So we started to look at this saying, well, it's not yet there. It's still going to take a bit of time, but still we are starting to see some machines. The tech is out of the lab. It's not research anymore. It's more entering the field of engineering, and the application and the time to get to products. First product, of course, are not perfect, but the first product with which we can do something is really the length of a fund. We are a long-term fund, 10 years can become 12. So when we started back in 2018, we thought, well, we have 10 years ahead to show that we can do something with the technologies. And when you think about it, so quantum computing was probably the most remote thing. Quantum sensing was a bit more ready, quantum communication as well, but then it turned out to be probably, but we'll think about that in more detail, it turned out to be quantum computing that triggered all the attention and most of the developments as well. So yeah, could have been a bit foolish, a bit of a bet back then, but we thought it was the right timing. And I believe if we had not started back then, it would have become much more difficult, because since then, some people have started and there's a bit more competition now.
Absolutely. Thank you for the introduction. And that gives me to the first question. You started the fund 2018. Philippe, you mentioned that you were at Inpho pitching for startups. After 8 years, if you have to name one of the quantum milestones that will matter the most over the next 5 years, what could it be and why? Who wants to start?
Well, okay, I can start.
Okay, perfect.
I think it's very interesting, like what Olivier just mentioned. I think if you think about the year 2015 or 2016, there was really a turning point between where we could see the emergence of a transfer from high-level academic knowledge that was built in the laboratories to the beginning of startups. I mean, yeah, my startup was a little bit younger, but it was really it's in this time that we've seen the growing interest into making quantum technology a technology and not just a knowledge and a science. What we see happening now is a second acceleration. So it's not the second revolution, but it's the second acceleration of the second revolution in a way. We see now companies that have values of billions in the public stock market. So this is not just a startup problem anymore. This is not an emerging technology. This is a phase where we are starting to consolidate the technology and to really build what we can call the quantum industry in a certain way. So this is not trying to put technology on the market. This is really going into what was before demonstration that science can become a product into the demonstration that a product can really have an impact in society. And so the milestones are getting the first fault-tolerant quantum computers that can show that you can actually do actual calculations, getting sensors to a level where you can actually deploy it largely into areas that are very useful, that can be in life science, that can be in Earth observation, and etc. And if you think about the challenge of communication, even if it was advanced, there are still a struggle to see what is the best solution to be quantum secure in the future, to have data that will be preserved with the fault-tolerant quantum computer that will soon appear probably. So it's not one milestone, it's many milestones, but they all relate to really changing from demonstration that we can make a capacity with quantum technology to actually using this capacity to do something and to really enter the market in a real way.
Which is quite related also to what Olivier you were saying just before, if I'm correct.
Yeah. And I won't add anything particular to what said Olivier and Philippe. I absolutely agree with them. I just remind that in the early 2000s, when came the technology, for example, of CPA system, laser with ultra-short pulses, everybody believed that microimagining would be the first killer applications. And indeed, the CPA system, so the Nobel Prize of Dr. Mourou, became a real success on the market because of ophthalmology. And it was a surprise at the beginning. So what I do wait for now is a killer application which will make the quantum technology really go out from the lab, from the startups, but to become a success story on the market. So it seems to me, and I do believe that the maturity of the technology is compatible today with this milestone in the 5 next years.
And yeah, if I had to give just one, I think it's the day someone starts using a quantum computer in production. Because today we are having about 120 machines that are deployed worldwide. So it's nice, already starting to show how it will be useful in the future. But now if a bank was coming and say, okay, I want to use this machine as a simulation tool in my everyday processes, I don't know, to detect credit default, for example, they wouldn't be able to do it. First, probably for a question of reliability of the machine and online time, although some machines have proved that they are above 95% time running online, so starting to be quite good, but probably not exactly at the scale on which we want them to be, probably not exactly ready to be set up in operational processes, everyday processes of a corporate client. So to me, that would really be it. And I believe it's something that can be achieved in the next 2 or 3 years. But for that, we'll need bigger machine and more reliable machine.
Thank you, Olivier. Let's bring me to the next question, actually. it seems clear that the quantum timeline is accelerating. I mean, 5 years ago, when you spoke about quantum computing, people were saying 20, 30 years. Maybe some believer, like very active on quantum, will say 10 years. Now you said 2 to 3 years, so it's accelerating. But if we are speaking frankly, which milestones are real and what is still a narrative for investor where we want to show that we believe in what we're doing and we are committed, but what is real, what according to you, Olivier, what is real? And then I will give the floor to Philippe.
Well, I think, for example, a good example of the belief that some people looking a bit from far away have is the fact that it's already useful. And we are still looking for the use cases where it's useful. When the Willow experiment came back in November 2024, well, it had been known by the community since August 24. So what happened with Willow is that Google made the demonstration that you are able to get to quantum advantage on a theoretical problem using quantum error correction. So the more you compute, the more your computation will converge. When it used to be a different setting where the more you compute, the more your computation diverge. And so it's an important step, and really it's an incredible step, but a lot of people got confused with that step, thinking that we are already able to use the machine in a significant and meaningful way to address some business problems. And really, to me, that's not yet the case. We are getting there, but it's probably going to take another 12 to 18 months. And that's probably the strongest misbelief that people have when they look a bit from far what's happening in quantum.
Interesting. Philippe, on your side.
Yeah, so I go back maybe on the quantum computing aspect a little bit later, but with respect to quantum technology, there is a lot about quantum sensing and also a lot about quantum communication, even though I agree with what Olivier said before. I mean, that's really quantum computing is probably the biggest market or the biggest market potential for a couple of reasons, not because sensors are not useful, but because most of the sensors we do have every day are very, very tiny, and our quantum sensors, they are probably overkilling the performance that we need there. But there are some applications or some real case that needs to be covered. I would say one of them for sensing that is about navigation. I mean, it's something we discussed a very long time ago. I think the first discussion about can you use quantum technology for navigation already happened 30 years ago when I was back in the States. But of course, the technology was not mature. But now it's not that the technology is mature. There is a need to push the technology, but there is also a need to change the technology. There is today, GPS is not good enough in the sense that you can hack GPS and then you cannot navigate. Plus the fact that you have so many, for example, autonomous vehicles, the density of the air traffic, that a GPS breakdown would be catastrophic for it. So you start to have a real need with a real answer. And this is actually already a milestone where the need of the user and the technology offer and the maturity of the technology actually start to match each other. And for sensing, I think we're entering now a phase that we will have to develop quantum-enabled navigation systems that will navigate without GPS in the future, and it will happen and this will accelerate. Now going back to computing, I think we have seen with the Willow experiment and also the achievement that were done with cold atoms, that error correction, that was, I think there is a before and an after those announcements. The before was, fault-tolerant quantum computing will never happen before 30 years or so, and let's focus on nearly intermediate, like noisy intermediate scale quantum computers, because that's what we can achieve today. They won't be good, but they will do something. And then all of a sudden, the paradigm changed because error correction was not a prospect, but a reality. And I think the next milestone is this reality. Let's have the first fault-tolerant quantum computer that can run, and that can happen within a few years, probably. That's not going to be the ultimate fault-tolerant quantum computer. That's going to be the first one. And there are some technologies that will allow to reach it, the technology that have been announced already, whether from Google or maybe from companies like Pascal. There will be other technologies that can pick up the pace later on. So this is a continuous process. So, and there will be maybe a first generation of fault-tolerant quantum computer that can deliver a certain computing power, maybe not fast enough, maybe not scalable enough. And then there will be a second generation later on, but the real milestone is to get to this first generation ASAP in a way.
Interesting indeed. So you highlighted different points actually showcasing that, of course, we speak a lot about quantum computing, but also quantum sensing, quantum telecommunication. And as you said from the beginning, Olivier, the challenge will be also to connect with the actual market roadmap, and the access to the market is very important. And I guess for investors, that's one of the key aspects, because if you don't deploy on the market, it doesn't make any value at the end. You can make a lot of promises, but you need to prove the market side. So you mentioned a lot of different points, the quantum computing, the quantum sensing, quantum telecommunication, but actually if I'm a startup right now, if I have my own quantum company, what will be your advices? What market should I focus first? Of course, you will tell me it's dependent on your technology, but looking just at the global side and the global view, what will be the first market to target, and where could I start making revenue before this fault tolerance is ready? And that's also very interesting on your side, Olivier, because we want to understand how you assess company, and on your side, Johan and Philippe, more from the technical parts.
Maybe a few figures on the market. So quantum computing is already a 2 billion market per year, and it's growing 50%. The reason for that is what I mentioned. There's over 100 machines that have been sold and deployed in data centers. You can also buy or purchase some runtime on AWS, on Azure, on the private cloud of the providers, on OVH as well. And there's also the development, let's say use case development market. So kind of consulting, where typically you're a bank, you want to implement a use case, and you will work alongside the companies like Pascal. It's a 6 months to 1 year program to develop your own algorithm, and it will be like a paying proof of concept. So all that makes for a 2 billion market yearly. So if you are one of the leaders of quantum computing, then you're already doing tens of millions of revenues. That's also the biggest promise, because that's where the big stakes are. So this market will probably evolve into several tens of millions market in the coming years. Now, quantum communication, it's a technology that's probably a bit more mature, but that's taking a bit more time to develop. There is a market. It's more like a proof of concept market. We are seeing in Europe 10 to 15 companies doing quantum key distribution, and typically hitting revenues of 1 to 2 or 3 million by developing, let's say, reasonable size, like 10 to 15 kilometers network, in which they have a few nodes where you can test architecture. But so it's still a proof of concept market, and we do not see yet any sign of, let's say, industrial or at scale development. So really, to me, the question in quantum communication is when will that happen? There's also the PQC market, post-quantum encryption, where it's been expecting to take off for quite a while as well. Now, I think with the threat of the quantum day becoming nearer, it should be the case. Also, strong push from the authorities. There has been some new orders from the White House that are pushing the deadline and want people to transition much faster. So this probably will have an impact on the market. And the last one, well, Philippe mentioned, quantum sensors is quite nice, but it's also a sum of a niche market where it's difficult to get a company in more than tens of millions of revenues. So there are different dynamics there, but definitely I think in the long term, or even in the medium term, those markets should all grow significantly, a bit the same way that what we are seeing in quantum computing right now.
And my question for you, do you see still room for companies in quantum computing? If we have some company very early stage right now, will you have a look to them?
So you're exactly right, because it's exactly the question we asked ourselves. We've invested in about 7 companies doing quantum hardware in our fund 1, and we had done 1 in our fund 2, and we were thinking, well, there's about 70 companies that have been started addressing 5 or 6 different modalities. They've received financing in tens of millions. So if you come now, what can you do to compete? And I think it's a bit what Philippe mentioned. There will be some new concept, new architecture, and people that will be able to disrupt this first generation. So what we are now trying to find is those companies that have a specific angle where we believe that they can leapfrog the people that have started now. So that they can have advantage on using new species of atoms, for example, a new architecture to go 3Ds where others are doing 2Ds, better type of qubits or embedded error correction in order to require less qubits. So there are some new concepts appearing quite often. And we believe those concepts have really a chance to get to scale. Also, the concept of spin qubit with CMOS technologies. Of course, if you're able to manufacture your qubit in a foundry, then you can get to scale much more easily. I think there's still some chance. Of course, it will probably be a bit harder, but we've done a few recent investment in a new generation of hardware, and we believe they have their chance too.
And last question before we jump to Philippe and Joanne. I'm just taking the opportunity because you're here, Olivier. But about the sensing business and communication, you said the market is not there yet. Do you see some drivers that could have an impact on the market for the years to come?
So definitely what we are seeing, and which is a bit disappointing, we would think that people want to prepare proactively because they believe the threat is real and is coming. But in fact, the only real driver is regulation. When you start seeing a state saying you need to transition and that will be compulsory, then people start doing it. Before that, there's really a few people that anticipate.
Yeah, and regulation is a challenge as a driver because it can change. Yeah. Okay, good. Thank you, Olivier. And we'll come back to the question of capital just after. But I'm very interested also on your point of view, Joanne and Philippe. Joanne, very active also at the technical part with the McKinney centers, to develop also some new technologies and bringing them to the market. So what is your point of view?
Yeah. So to follow what Olivier told, this is a reality. Today's there is a quantum ecosystem. This is a real landscape which is very interesting, and revenues are here with quantum sensor, atomic clocks, communications, and all the enabling tech. So we see that as a guys from lasers, we see a strong grow up of our collaborators from photonics with this enabling tech. So I don't think that the strong message I would like to share is that we must follow the development of these markets with strong investments also in fundamental research, because what we are discussing today follow more or less what was done by Alain Aspect or Philippe Grangier in the 80s. So it is very important to follow the investments in industry by investment in fundamental research. And a tool that we like to use, particularly at IOGS, are, for example, LabCom, laboratoire commun between players like Pascal, for example, which has a laboratoire commun with Laboratoire Charles Fabry, or Toptica, which is a provider of lasers and quantum technology, with a common laboratory with LP Twain. And I think this is really this is not only a technology transfer that you can do, but an accelerator of the time to market. For example, today, laser which is developed at Bordeaux at LP Twain is 6 months later on the market. And so I am sure that a good fueling of this industry, this lab to industry road is very important, and we have to reinforce this. And Philippe, what's your point about this?
Well, first, I think because the numbers that Olivier mentioned about the market, I think we have to be aware that it is mostly a B2G market. with a little bit of B2B market. And a big part of the B2B market comes from, let's say, well, you mentioned it, Johan, like enabling tech or enabling components, or let's say the companies that can play a significant role in the value chain, which is, for example, a very big part of the startups we do have in the Netherlands. They get the wires for the fridges, they get the chips, the testing capacity. There are lots of those companies that actually do have a growing market today, because the quantum computing company need these components, and these components need to improve as well. So there is not only to relate to your question, not only there is a growing market, but you also need to have a roadmap which adapts, because if you are missing evolutions of your products, then you are actually missing the market and the next phase of the market. So there is a challenge there for a lot of companies, not just to develop their own technology or their own subcomponents, but to be the best in the competition and to really have a roadmap that fits also the development of, for instance, quantum computing and quantum computers in there. You mentioned regulation. I think that's a very interesting and important point. Yes, regulation can change, but there is indeed a role of, let's say, the government, not just to acquire machines because they need it, but also to like, if they think that this technology is strategic, they need to facilitate the development of this strategy. I give an example. I was at CES a couple of years ago, and I was trying to talk to some people doing the public key infrastructure for autonomous vehicle, and say, well, but why don't you? I mean, you're like the most threatened infrastructure by an attack there. So why don't you switch to PQC? Because then at least you're gonna be like secure. And then NIST has released all this library, and they say, if we are not told to do so, we won't do it. So even if they know it is needed, you need to have signs. And for example, for the PQC transition, there are now very strong signs from the national agencies like ANSI in France to say you need to make a change. I mean, I think in the US they say if you don't change within the next 2 years, then you're gonna get fined, because you're not gonna be secured. So you need to push that. It's not just regulation. It is also like the governments using tools to push the technology they believe it is important for their country. It is also, they believe it is important for the development. Again, because in the US, if you look in the US, I mean, internet has developed because they made a very strong decision on developing the data there. So the fact that you have a market now, it's not the market did not decide on internet, the market adopted internet. And I think it's good to get market pull of the quantum technology, and we're all working on it. We're trying to push it, but the market will probably adopt quantum technology. They will not make quantum technology. So we need to make it, and the government have to help us through programs that are helping the companies, procurement programs, to development programs, to infrastructure programs, because then the market will actually adopt this technology. But the market is very, I mean, NVIDIA is a very good example. I mean, the market adopted NVIDIA. The market did not create NVIDIA. But now NVIDIA is like one of the strongest players of chips. And this is exactly the problem we have. We have to make roadmaps on government level, like UDNL is doing this, in order to help government to make right decisions to develop the economy and the industry, or to be the factor. And the company have to make the roadmaps as well, because they are also driving the evolution with respect to this.
That's a good transition indeed to with the case of NVIDIA. The driver is apparently AI. So that brings me to the next question: quantum and AI. Is it a complementary capital cycle? Because we know that a lot of capital is needed on those two topics, especially when we speak about AI infrastructure, and quantum is also an infrastructure. So according to you, and again a question for Olivier, do you think that it's a competition for the same dollars, talent and compute? Is it competing? Is it complementary?
No, I will start by saying that it's on everybody's mouth these days that there's a convergence between AI, quantum, and HPC, high performance computing. And those three will develop hand in hand, and we are now seeing proof of that integration in the data centers. Player like NVIDIA that Philippe mentioned are developing orchestration layer in order to be able to break down the computation to the most relevant chip to perform the computation. So those technologies are really working hand in hand. Now, of course, they are competing for the resource. When you are seeing the amount that's been invested in AI, it's hundreds of millions. And when you look at the price of infrastructure, the factories that you need to build, it's really a lot of money. Whereas in quantum, we've been a bit more sparse. Investment in the quantum startup used to be about 2 billion per year. Now up to 10 million last year, but so it's really tiny compared to what there is in AI. And we are starting to see also evidence that for some of the best talents, it is difficult for the quantum industry to pay as much as the AI industry is able to pay. So not speaking about the pure quantum physicists, which of course will remain in the field. But if you look at the quantum startup, it's both using specialists from AI, from programming, and for those, let's say, more generalist profiles, then that's definitely is competition. Also competition from the not only the private money, but the public one. Because if a state decide to build a gigafactory, AI gigafactory and to sponsor it, of course there will be a bit of quantum in this, but most of the money will go to AI as well. So yeah, competing for money, competing for resource, but I think it will over time re-equilibrate when people see the value that quantum can add to AI, as we are seeing today what AI can bring to quantum.
And will cybersecurity part of it? I mean, that could be an additional value.
I think by design, of course, yeah. I mean, people are more and more aware that you need to be careful with your data, with your application, and so yes, I don't think we are designing the data centers in the same way that we used to.
And energy saving, part also of the equation to value further the added value of quantum?
I think it's also a necessity. I mean, there are some countries in which you cannot even afford to build a new data center because you just don't even have the power supply. And I find it quite nice. Well, I don't know if it's nice, but quite strange this transition where we used to speak about petaflop, exaflop, so compute power, and now we are speaking about kilowatt. And it's quite, I think it shows that we are now dealing with energy even more than compute.
Totally, yeah. And as you mentioned also silicon-based and semiconductor-related relationship with quantum. Is it the bridge to industrial scale? We have an interesting company like Cobley that has been a very interesting fundraising, and we were very happy to see it because they were part of Inpho 2 years ago. So what is your point of view on that? And I will give the floor also to Joanne and Philippe to share their feedback.
Well, I think regardless of the technology, I mean, the path is always the same. It comes from deep research in the lab. So you have a very bulky experiment that's taking the size of a whole room. And the end goal is to make it into an industrial scale product. So if it's CMOS compatible, then it will go on chip. Even if it's photonics compatible, you will start with your laser and your optics, and it will end up as well in a photonics integrated device. And you need this to be more reliable, you need this to cut the cost down, and you need it for industrial integration as well.
So Philippe and Joanne, from a technical point of view, do you see some emerging trends that will answer those questions and further value the importance of quantum and its shares in the capital allocation?
Well, oh, sorry.
Yeah, go. No.
So there is an obvious one that I think Olivier already raised a little bit, but you see now a lot of AI is used in order to, for example, develop the error correction codes for quantum computers. So AI is already helping a lot in making the process of our quantum technology and especially the quantum computers more efficient. So that's a direct consequence of the capacity that AI has to optimize processes, to optimize workflows, and etc. And at the same time, it's very hard to distinguish quantum technology from semiconductor technology, because if you look at it's not even for spin qubits, but it's for everywhere. You need silicon chips everywhere in a quantum computer or in any kind of quantum sensor. You need specific chips as well. So I think that's where quantum has actually also pulled the semiconductor industry to develop specific chips that can, for example, operate at ultra low temperature. Because if you want to put an amplifier or a data analysis system into like at 4K or at 100 milli-K, that's not the same chips that you have otherwise. And maybe it's not a big market today, but this is actually also putting some developments there. Specific chips also for control, because you need sometimes faster control and more complex controls and etc. So there is already a very strong connection, and it's accelerating also in the sense that if you extend semicon to integrated photonics and etc., this is probably one of the challenge of the future, is to really get your quantum machines much smaller, much more integrated with much more industrial process, and all these photonics chips systems and photonics integration capacity will play a significant role and will drive lots of development there. Yeah, so should we change teraflops into gigawatts? I mean, that's a very big problem in the Netherlands, as you might know, that we need power, and we can have the power, but it's not just to have it, it's also to bring it to the right place if you want to make the computation. So actually, reducing power consumption is very important. There is maybe a way for quantum computing to help AI in that way to be more efficient. It's yet to be proven, so I would not say this is the solution or this is not the solution. What I see now is more and more the will to indeed go to a joint, let's say, infrastructure where HPCs are integrated quantum computers, but even more that quantum computers are becoming a part of HPC, in the sense that you don't build a quantum computer to build a quantum computer, but companies are starting to build basically quantum computers that are compatible with HPC. So that HPC is probably one of the major integration environment for the future of quantum computer today. And this will develop even further, I think, over the next years. And this is probably one very important route. That also, to go back to a question before, is giving some, I know like some former founders of quantum computing company in the US are starting like a company dedicated, or at least what they say, dedicated to be integrated into HPC facilities. So looking already at building a quantum computer for AI and not trying to see if a quantum computer can help for AI is also a big change that we see nowadays. And the fact that NVIDIA is also now pushing a lot into this, this is showing the potential there, yet to be demonstrated again. So yes, I think that's three technologies that will have to live together. And that will have to develop together. They are addressing a different market in the sense that AI is the most closer to the public, so it's the most closer to the customer in a way, because you, even though and the hardware which is feeding the AI is then really where quantum and semicon can play a role together.
Right. You have a short comment to that, Jean, or we go to the...
Oh, maybe to summarize the intervention of my two colleagues, I think as engineers, we don't really care which technology will win. What we care is we care about building systems that will solve the problem. So it can be AI, it can be quantum. They are certainly complementary. Silicon is by nature incredibly attractive. It offers the decades of industrial know-how, and so it's very it's an interesting material. But will it become the universal solution? I'm not that convinced. I don't think that all of three know the platform that will win at the end. They have their strengths and their limitation, neutral atoms, trapped ions, superconducting. And personally, in what I do believe is that maybe hybridation of this platform. I do not see a quantum ecosystem living only with atoms without the photons. What we call flying qubits have to live with the neutral atoms in the future. And so, like classical computing combines CPUs, GPUs, FPGAs, and etc. Future quantum systems will hybrid all those platforms.
Very interesting indeed. This hybrid point of view is something that we also discussed deeply within the Inpho Venture Summit committee. So I think you have also a very strong point here, Joanne. A very quick question before we jump to the presentation of Inpho and also taking all the questions that we have collected today. Olivier, where should we, as an investor, deploy capital today? Hardware, enabling technology, software, sensing, post-quantum security? You already answered a bit through the discussion, but if you had to say it in 2 words, what would it be?
I think it's a bit easier for us because as a fund, we are building a whole portfolio of 25 companies and we try to have a balanced approach. So several modalities of qubits, several types of companies, hardware, software, enabling technologies. So yeah, it's a bit better for us. It's a bit easier, but I think they have different risk and reward profile. Of course, the moonshot is really the hardware in quantum computing because those companies have the potential to have valuation in the billions of euro. But there are also probably some nice plays in enabling technologies or in sensing as well. Communication, I think, will play a big role also when the machines, when the quantum, when we are getting closer to the quantum threat. Now, one thing that's been a bit difficult is the application layer. I think we have not seen as many companies as we should have in that field. We also believe that it will be strongly disrupted by the AI LLMs. And by the way, if you have not heard it yet, we've discovered in the last few weeks that Claude Code can code on quantum computers. So that means it lowers the barrier to entry for the end users. So I think, to me, it seems in the long run, the probability is that there will be some value in the hardware because you need the machines to run those programs on. Now, is the value going to be directly at the final user because they will be able to do it by themselves using the AI tools, or is the value going to be in software because the software company will have nailed how to find the right use cases for quantum computers? Still not clear, but I tend to believe that value is going to be polarized on both ends, either at the user side or in the hardware.
Very interesting. It's always the application that drive everything, and indeed the use with Claude. I didn't know, I was not aware of that, so very interesting. Thank you for sharing. And that's exactly what we'll discuss. You mentioned also it will be interesting to have some company more focused on the application side, and so we have participants in the room ready to come to Inpho. Don't hesitate. Just a short introduction, but you all know about Inpho. As I said from the beginning, it's here to dedicated for investors, to meet with investors, and so to discuss investment opportunity through a selection of startups invited to pitch and to meet with investors. We always have the wine tasting, obviously, because it's always nice in Bordeaux. And this is the different topics that will be covered: compute and AI and data infrastructure, hardware and enabling deep tech. Very important, including quantum technologies, physical and bio-inspired systems. The goal is also to look at the application side and also to leverage on those technology, AI, quantum, and also physics with physical AI, growing market now, defense and dual use, and also deep tech for critical infrastructure, which I think also quantum is, for me, also part of this infrastructure, which will open also the question after on the capital needed, and as investors, how much do you need also to support further those companies in their growth? And just for the company, we are currently selecting the company that have applied to participate in. So if you still haven't done it, you can still contact the team at Blumorpho, but I don't know if they will accept it because the deadline was the 1st of July. But in any case, if you still want to apply and meet with investors and benefit from Inpho, you can still try to send your message to the team. So now we are entering into the last phase, which is a one-sentence session. So I will ask you questions and you need to go straightforward in the answer with one sentence. So how fast is the quantum investment window really opening? Who wants to answer that first? Philippe, do you have a point of view from your side at QDNL and Nakidis and other key activities you are running?
Yeah, I'm not sure about the question. I think.
Do you think that the investment opportunity is for quantum companies is really opening now and fast, or you see it more like
it is opening fast?
Normally.
A lot of our startups today, they need the investment. They are actually growing very fast. I mean, it's not just even about seed money now. We are like looking at Series B or even so it is opening now. It is really opening now, and it's usually fast because the market is, or like the competition is going fast. So fast and now. Quick
fast and now. Olivier, I think that you're currently raising a new fund with Nation.
Not raising a new fund exactly in September, and yeah, we strongly believe that the window is here. Well, the amount invested in quantum startups last year has done ×5. We see no sign of this going down. If you look, Continuum raised 2 billion in June. IQM just raised probably about 250 to 300 million. Pascal is going to get listed on the Nasdaq as well. That's for the private side. Now, if you look also, the US administration has directly invested 2 billion into startups, 1 billion in IBM, 40 million in companies like Dirac, for example. We are also seeing the national plan that are recharged with new money. It was the case for France with 1 billion last month from President Macron. So yeah, we are getting closer to maturity, closer to application. We need to build more machine. Those machines are starting to be useful. So yeah, definitely there is more attention. And those figures are not even taking into account all the money that's been invested by companies like Google or IBM or Quantium when they were at Honeywell, NVIDIA, Amazon. So yeah, I think it's strongly accelerating.
And so now if you look at the quantum cap table for a company, what should it be? Because that brings me to the next question, because sovereignty is part of the game from my point of view as well. So you said also that it's definitely also a government market for the moment. So do you have a point of view on that? If you look at the cap table for a company, and does it has an impact on the sovereignty, and is sovereignty impacting the fundraising of company? Do you have a few words about that?
Well, I think it does, of course, but the situation is very different. If you are a US startup, then it's not complicated to find lead investors and have large rounds of financing in hundreds of millions. If you are a European startup, it's much more difficult because we don't have those kind of investors. Typically when you invest at Series B stage in a quantum startup, you still have the VC risk, but associated with growth money. So it's something that's very difficult to find in Europe. So for that, we need to rely on sovereign capital to some extent. Now, relying on sovereign capital for 20 or 25% on your cap table, that's not a big risk on sovereignty. And I think we should be careful using this word of sovereignty. People often make the confusion between governance and the financing. You can finance the company, but still keep a big degree of national governance and some sovereignty as well. Now, also something not only on the financing side, but also on the market side. Of course, there will be some implication on markets because there will be some export control rules at some point. And also probably something that people are starting to realize now is that the supply chain is becoming critical. And if you want to keep your sovereignty, it's probably more important to secure your supply chain than to have 10% of sovereign investor in your cap table.
Interesting indeed. And Philippe, And Johan, you are also part of national and regional activities. So maybe you can also share a bit more on NACTIS and Nouvelle-Aquitaine, France, and also Netherlands, how you consider that.
Maybe concerning the sovereignty. So yeah, this is very important for a current company which works in quantum. Can you manufacture? Can you qualify your system? Can you build a resilient supply chain? This is very important to build it at the French as the franchise, but also at Europe size. This is what we do together with Philippe, for example. We do believe that programs like Atom Control at the French level or NACWIDIS at the Neo-Aquitaine level is very important. And what is very important also is to keep our talents. We need to keep sure that we keep the critical knowledge, the key technologies, and we don't have to copy what is done in US or China. We are building together our own strengths, scientific excellence based on history. Philippe, we have a very dynamic enabling technology industry, a collaborative research model which is very interesting in France. So I think that we have a lot of strengths to play in the next months.
Thank you for this positive, also an inspiring point of view.
Yeah, just maybe to give a quick oversight. I will try to be short. I mean, the numbers, Olivier gave the numbers, and you know the numbers better than I do. But I think what we're facing basically in Europe, and it's valid in the Netherlands, but everywhere, is that companies that start to need an investment round of, let's say, roughly 100 millions are really entering into difficulties. And then sovereignty comes with two things. There is sometimes a difficulty for these companies to have external investors because they are, as Olivier said, like too much involvement of these investors can be seen as a risk from the government. But it also can result, and we've seen a few examples that no capacity is given to this company to raise enough, and then they have to go abroad. And we've seen from a company acquired by IonQ and etc. Mostly because we don't have. Contonation has been very successful, but it can only invest to a certain level, and we are missing a multi-billion kind of investment capacity in Europe. That can actually do the same that is done in the US, for instance, and that's really a challenge now. This is something that needs to be built in order to give this capacity to our companies to keep on growing without being acquired by bigger companies.
And it's true that the success of Contonation will inspire more investors to invest, I'm sure, and also to raise a higher fund, I hope, to support more companies and support them in their scale. But maybe in the 2 minutes that we have, I'd love to take some questions. So we have one question, which is data center energy and power just came up as a binding constraint. Photonics investors are betting optical interconnects solve part of the classical side. Where does the photonics roadmap intersect with the quantum roadmap? Are they converging on the same energy and processing optimization answer, or racing on separate tracks that never meets? So do you see convergence between photonics and quantum? Who wants to answer that?
I can answer that. Well, there is a lot of convergence. I already mentioned a little bit before that there is a lot of photonics in a lot of the computers, some of them more than others, and you need integrated photonics there. Then the interconnect will have to use photonics, and there are, like say, a vision of the development of quantum communication is the future quantum networks. And the quantum network will not be a quantum internet to browse on your browser, but will be a way to connect quantum computers from one side to another with an optical interconnect, and eventually an like a transducer systems that can transfer the quantum properties of the photons to the quantum properties of, for example, the radio frequency that you need for a superconducting quantum computer. But the quantum network interconnect that is needed to get the quantum computers to hook together is very important. It's being currently developed through infrastructure, and this will be the future of large-scale quantum computing, probably.
Thank you, Philippe. And the last question, because I know we are running out of time. Olivier, you made a comment on the production readiness for quantum computing. Could you give more details about according to you, the main engineering bottleneck preventing the systems from reaching production level reliability? Perfect.
Yeah. Several aspects to this. So first, all technologies are not equal. If you look at the Candela machine that was installed at OVH, I think it ran for several months without needing any calibration or without drifting, 100% runtime. So photonics is quite stable and was fine. Some other technologies need a bit more, let's say, downtime. This is due to alignment program, calibration, but it can also be due to maintenance. You have some laser you need to change or things like that. So resulting probably, if you look at an Atoms machine, it's probably 1 hour to 2 hours downtime per day. So, I mean, not something that's is impossible to be used in production, but I think the real bottleneck is not only machine by machine, but simply the fact that we don't have enough machine. There are stats saying that on the Fortune 500 companies, there's more than 300 large group in the world that have quantum programs and want to develop use case on quantum computer. So if you have just 120 machines worldwide, and it takes 6 to 9 months to build one machine, then it's really one of the barriers. We are not yet at industrial scale, and we don't have enough machine. That's also one of the key bottlenecks.
So in the good way, but still a lot of work to be done and a lot of investment to be distributed, actually. So we count on you. Could you just share as a conclusion the fundraising you're doing right now? What will be the size of the fund?
Yeah, so we're trying to raise a scale-up fund exactly to do what Philippe said is missing today. So being able to finance rounds of 100 to 200 million, mainly in Europe, with a lead investor check of 25 to 80 million. And so for that, we are raising an 800 million fund, which will start in September. But I think there's been good response because this fund will be centered on more mature companies. So for people who are a bit afraid that quantum is still early, then we'll find companies that have revenues and have already been a bit de-risked. And also it will be a shorter fund, not the 10 years that we usually have, because we will be closer to exit. So that I think we should have quite a good success with investors.
And something I'm happy to discuss during October event at Inpho Venture Summit.
Pretty
Expecting
sure.
to have LPs as well, so it will be interesting to highlight it clearly. Thank you very much for your time. It was very, for me, a great pleasure to discuss this case with you. As I said, we started discussing about it in 2018, so it's good to see the great progress on this topic, and also to see the evolution of the Continuation Fund. All your activity, Philippe, from the first discussion you had from your startups to all those different ventures you are currently developing. So congratulations also on your side. And Johan, of course, the NACID Center, which is also close to my heart, with the strong activity of Audrey Durand, who I know for a long, long time now, very dedicated to this topic for many years. So always good to see the progress. So thank you very much again. I'm looking forward to see you all in Bordeaux to further discuss this. And for the participants, don't hesitate to contact us for any questions. Thank you very much.
Thank you very much. Thanks a lot.
Thank you so much.
Bye-bye.
Bye-bye.
Bye.